Top-down network design. It's a CiscoPress text. Chapter 1, Analyzing Business Goals and Constraints. The normal question is, why bother analyzing business goals and constraints when we're talking about network design? And one of the big questions is, network design should be a complete process that matches the business needs to available technologies to deliver a system that will maximize the organization's success. Essentially, the network has to match, or the technologies of the network have to match the business. If it doesn't, then the business isn't maximizing its success. In the LAN area, it's more than just buying a few devices. In the WAN area, it's more than just a phone company. These are specific design requirements for a specific organization to maximize that organization's success. So let's start at the top. Don't just start connecting the dots. You have to look at the business and technical goals first and understand them. Understand the business goals and objectives for today, tomorrow, and next year. Explore divisional and group structures to find out the network servers, services, and where they reside. Determine what applications have to run. What network components for each application. What are their requirements? Focus on layer 7 and above first. Meaning, let's focus on the application and end user. Remember our 7-layer of our OSI model: application, presentation, session, transport, network, data link, and the physical. Those are our 7 layers. So the structure design, a focus is placed on understanding the data flow, the type, and processes that will access or change data. Here we're focusing on the data itself. We have to understand how it's going to flow from end to end, from server to client, from client to end user. The client or the end users could be internal, could be external. Who's going to be using it? What's going to be the data flow? What data types are going to be? What type of processes might manipulate that data? Does it have to be secure? Does it have to go between locations, geographical locations or continents? All those other things that you have to understand before we can start designing. Another focus is placed on understanding the location and the needs of the user and the user communities that will access that data, will use that data, and will process that data. Several techniques and models can be used to characterize that. One of the big ones is new user requirements and structure for future system design. It's a logical model. It's developed before any physical model is selected. The logical model will represent the basic building blocks that will divide the network into functional logical groups and will underline the overstructure of the system. The physical model represents the devices and specific technologies and implementation. So how do we design these? So if you've ever done software, you should be pretty familiar with the System Development Lifecycle, or SDLC. Doesn't mean synchronous data link control or system development lifecycle. It really just depends on the course. This is a fairly common acronym, so keep that in mind. The typical systems are developed and continue to exist over a period of time, and that's that life cycle. So is there a graphical representation that we can look at? Here we go. We develop logical design. It kind of depends on what layer we're working with. We analyze requirements, develop logical design, develop physical design, test, optimize, document design, implement, test network, monitor and optimize performance, and start over. Over and over and over. Phase 1. We analyze the requirements. It will analyze business goals and constraints, objectives, both short-term and long-term. It will look at technical objectives, technical goals, and trade-offs of such technology. It will characterize the existing network, what components are good, what components are bad, how it's laid out both logically and physically, and it'll help to characterize network traffic. Phase 2, the logical network design, that will be the network topology design at the logical view. It will design models for the addressing and naming of devices. This will start selecting the switching and routing protocols, what type of STP might be used on the switches, what type of routing protocols might be used on routers. Is it going to be EIGRP? Is it going to be RIP, OSPF, BGP? What? If we're doing multiple site locations, are we doing frame relay? Are we doing MPLS? What layer 2 technologies are we going to be implementing so that we can have connectivity between remote locations? That's things that are thought about and done here. We're also going to start looking at a network security strategy as well as management strategies for that network. Security should be pretty much built into every layer. It's sadly not, but here is where we start having to really dive into our security strategies as we start designing our logical flow. Phase 3, the physical network design. This is where we're going to be selecting the technologies and devices for our network. If we're using MPLS, if we're using frame relay, this is what's going to be decided here. Then what devices are we going to use? Are we going to use all Cisco devices? Are we going to use a mix of Cisco and Juniper and Sonic walls? Here's where you have to decide what type of devices are we going to be using. This would also be selecting devices for our design. So it's not always about our campus network. It could be for an enterprise network. Big thing here is we're selecting our technologies and devices for our network, regardless of the type of network. Phase 4, the testing phase. This will test, optimize, and document the design. We'll test it, we'll optimize it, we'll document, and we'll repeat. We'll test, optimize, and document until we have the desired optimization. So, there's always this fun one. This is our PDIOO network lifecycle. That is plan, design, implement, operate, optimize, retire, or repeat. Plan, design, implement, operate, optimize, retire, or again, repeat. So next, business goals. Why do we care about business goals? Because the business is there to make business. Normally the business goals are going to be increase revenue, decrease costs, reduce operational costs, improve communication, maybe shorten life cycles, expand their markets, build partnerships, offer better services. So how can we take this and apply it to technical goals? That's the big thing. You have to remember the business wants to decrease costs and increase the money it's making. So trying to do network designs that are going to be too expensive while not really increasing revenue probably won't go very far. Other business priorities could be mobility, security, resilience or fault tolerance, could be disaster recovery or business continuity after a disaster. What projects are going to be prioritized? Are there any things that are going to require QoS or CoS? Are there low latency requirements for applications? Things like voice. So resilience means how much a stress a network can handle and how quickly the network can rebound from that problem. That could include security breaches, nature and natural disasters, could be error or catastrophic software or hardware failures. It's believed that some experts have a mild dislike for the word resilience, as it sounds too much like a stretched rubber band. So, depending on the book that you're reading, it might be called fault tolerance, not resilience. So, business constraints, budgeting, staffing, schedule, politics, and policies. How could they affect our network design? It's all about growth and scheduling. If we don't have the time to implement the technology, Because of schedule conflicts, that won't work. It could be political. Politics are always a big one. Could be staffing or expertise. Could be budgeting. They could just not be able to afford the current design. So these are all constraints that have to be considered when designing a plan. So first thing we have to do is do some basic data collection. Before our first meeting, we need to understand the client. Are they internal or are they external? We should also collect some basic business related information, like what do they do? What do they produce? What services are supplied? What are their financial viability? What are their customers? What are their competitions? Do they have any advantages or disadvantages? These are all things that you might want to be able to know off the top of your head before going into a new client trying to design a new network. That way you can tailor that network design to that business goals. So when you meet with the customer, you want to get a concise statement of the goal of the project. What problem are they trying to solve, or what solution are you trying to push on them? How will the new technology help them? How will it be more successful? And how will that help their business be more successful? Lastly, what has to happen for those projects to succeed? That's a big one. What will happen if the project fails? Are there any consequences to that? What are the mission critical or the critical business functions that must be there? If this project fails, will it affect those mission critical processes or functions? Is the project viable and visible to upper management? Are they on board with it? Who is supporting your design? Is management? Is it just end users? You also need to look and discover any type of biases. Some companies will not use Juniper equipment because one of their managers hates Juniper. So you need to understand the biases. You also should understand, do they avoid any specific types of technology? Some companies refuse to use BYOD. The idea of bringing user devices into the network is absurd to them. So you have to be able to understand the technologies that they're willing to use and not willing to use. Does the data people look down on voice to people or vice versa? One of the big things here is, can we understand the data? Are we going to be able to support the data and all of their needs? You also want to talk to their technical and managerial staff as well as end users. You want to make sure that you're understanding the full scope of the network design. Once all of this is ready to go, make sure to get a organizational chart. That way you have a general structure, who reports to who. But what about security? That's always a big one. Before meeting with the customer or during meeting with the customer, get a copy of their security policy. How is it designed? How is it going to have to be redesigned to support the current new design that you're going to be proposing? Will there be new designs that will affect the policy? How are you going to make those changes? Are you going to make those changes? All questions to bring up. Is the policy so strict that you, the designer, won't be able to do your job? That's always a good question. Start looking over and categorizing network assets and the security that it should be protected, and to what degree that security must be there. Look at things like hardware, software applications. You may have to look at intellectual property, trade secrets. How are those being protected? How are you going to keep protecting them? Those are all big things to look at and review. Understand the scope of the design project. Is it a small scope? Is it a big scope? Can you break the larger scopes into smaller several scopes or milestones so that you can complete them? Use the OSI model to clarify the scopes. Use the scopes to help fit the budget and capacity. and scheduling. That way you will be able to successfully complete the project. Gather more detailed information as required. Things like user communities, data stores, the protocols, the current architecture and performance, that should all be discussed. You should be looking at other business needs like applications. One of the first things within the research should be applications and how they're going to be impacted. Things like user communities, data stores, those are all really important things that you are going to have to know. So can we have some type of general chart for us to use? Sure. Here is a network applications general chart so that you can do the name of the application, the type of the application. Is it a new application? What is its level of credibility? Is it mission critical? Does it have to be the first item backup, second item backup? And it gives you room for comments. This should be done for all applications in a network. That way, if an application ever fails, you have a way to go in and manage it, recover it, and again, you kind of know what thing has to go first. So in conclusion for this is all a systematic approach. Focus first on the business requirements, goals, and objectives, looking at the constraints and applications, understand the customer and the customer's corporate structure, understand their needs, what are they wanting to do with it, also gain an understanding of the customer's business style. So last slide before we finish, some general thought questions. What are the main phases of network design per the top-down network design? What 6 items are there? What are the main phases of the network design per the PDIOO approach? Is that going to be repeat or retire? Why is it important to understand your customer's business style? Why is it important to understand your business goals, objectives, long-term wants? And what are some of the goals for the organization today? How might they differ from tomorrow? So that's actually it for chapter 1. It's a nice start of understanding business goals. So I wanted to thank you and I will see you next time.